Hello, and welcome to this lesson on solving systems of linear inequalities. So that's what's going to make this lesson different, is instead of looking at equations that we've been doing the entire rest of the unit, we're going to be looking at inequalities. That's the greater than, less than stuff. See, the central question says, how do I solve systems of linear inequalities? All right, pretty straightforward. For vocabulary, we have one. So a solution to a system of linear inequalities. Just like a solution to a system of equations, it was a point, an ordered pair, that makes both equations true. Well, with the system of inequalities, it's the same thing. It's an ordered pair, a point, that is a solution to all inequalities. So it makes all of the inequalities true. And we're going to see that very, very simply here in just a second. So here's our first problem. Our goal here is to graph the system of inequalities. So we're going to graph these two. And then we're going to figure out these points down below, which of them are solutions to the system of inequalities. Okay, so the first thing we can do is that first equation, we can graph him straight away. He's already slope-intercept form. Y equals mx plus b. So my slope is a -1. That is -1x, so that's my slope, and my y-intercept is a +3. So to graph that, my y-intercept is +3, my slope is -1, which means I'm going to go down 1 over 1, rise over run, down 1 over 1, down 1 over 1, and repeat, and repeat, and repeat. Please do not draw a line through this. Just draw the dots. Because there's something we have to talk about. So if you remember, when we were talking about inequalities, you remember that the greater than and the less than, when you graph them, have a hollow dot. It's like a hollow, not filled in dot. Meaning that those points are not solutions. And we saw that when we had a greater than or equal to, or I'm sorry, that one's a less than or equal to, and a greater than or equal to, those had a solid or filled in dot. Well, the same sort of thing applies with our linear inequalities. But instead of having a solid dot and a hollow dot, we're going to have a solid line and a hollow line. So this inequality, this line here, because this is a or equal to, this is going to be a solid line. So I'm actually going to go ahead and draw a line now through these points, and I missed them all. I'll move my point down, my line down here. There we go. Still need our arrowheads. Ba-boom, ba-boom. Now to graph my second line, I am going to, well, first off, erase this junk, but I'm also going to solve this equation for y to make it slope-intercept form so I can graph it. So things like subtracting 4x on both sides. You should be familiar with this by now. Subtract -4x plus 12. I'm going to divide by -6, divide by -6. Those cancel. Y is, that's going to be a +2/3 x minus 2, and I skipped putting my inequality here for a reason. If you were working ahead of me, you may have put the less than symbol and moved on and potentially made a mistake. Remember, when you're dealing with inequalities, anytime you multiply or divide by a negative, like we did here, we divided by -6 on both sides. When you divide by a negative, you change the direction of the inequality. So this now changes from being a less than to a greater than. And that's going to make a difference in our problem. So now this is the line I'm going to graph. So I'm going to need a dotted line. This is just a greater than. So I'm going to have a dotted line that, let's see, has a y-intercept of -2. Let me change color here. And this, all of this will make red, style red. There we go. So now we have a red line and a blue line. So y-intercept is -2. Slope is a +2/3. That's up 2 over 3. up 2 over 3. Up 2 over 3 and down 2 over 3 the wrong way. We do need a dotted line because this is just a greater than. Now, if you're using the iPad, there's a couple ways you can do this. One way you could do this is draw a straight line like this and then take some white and just do this. It kind of looks dotted now. That's okay with me. Or you could just use the red tool and just kind of go like dot, 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 something like that. It's all good. Okay, so there's my dotted line. But this is not done. So just like when we did inequalities on a number line, we filled in our dot, hollow or solid, and then we shaded to the left or to the right. Well, on our coordinate graph, we also need a shade. My first line here is y is less than or equal to. I need to shade less than or equal to this blue line. Now, instead of going like from to the left and to the right, like we did before, when you're talking about on a coordinate graph, less than is lower than the line. Less than is lower. So I'm going to shade everything lower than my blue line, below my blue line. So I'm going to shade all of this. Now I'm going to caution you that I'm going to shade a couple different ways throughout this lesson. This is the first way that people learn to shade. There's a better way I'm going to show you shortly. Okay. So this is the shade of this blue line. Okay. Now, when we change to the red line, I'm going to shade greater than this line. A greater than is above, oh, that's above the red line, greater than, above it. So if I would imagine going from my red line straight up, above it, that's the side I'd want to shade. Because that's where the solutions of the red inequality are. They're everything above this line. Now we are pretty close to being done. So let's look at which of these points down below here are solutions to this system of inequalities. So I'm going to graph each point here. So the first point here is -1, 1. -1, 1 is right there. Is this a solution to both inequalities? Is it in the shaded region of both inequalities? Well, yes. It's below the blue line, so it's a solution to the blue, and it's above the red. It's a solution to the red. So yes, that point is a solution. Let me graph the point 3, 3. 1, 2, 3, 1, 2, 3. 3, 3 is right here. Is that a solution to the system of inequalities? Well, it's a solution to the red inequality. It's in the red shaded in region, but it is not in the blue shaded region. It is not an answer to the blue one. So that is not a solution to the system of inequalities. The point 6, 2. 1, 2, 3, 4, 5, 6, 1, 2 is right there. Is that a solution? No, and actually for the same reason, well, that and more as the previous problem. First off, it's not in the blue shaded region, so it cannot be an answer to the blue line. But also, on a dotted line is not a solution to the inequality. If I would plug in 6 and 2 in here for my red inequality, we would find that the math actually doesn't work out. Let me show you. I'm going to delete this stuff. So if you want it, you might want to go back and rewind the video. If I plug in 6 for x and 2 for y, and I do this math, 4 times 6 is 24, minus 6 times 2 is 12, is less than 12. I'm doing the math on the left-hand side. That gives me 12 is less than 12. Is 12 less than 12? No. So that is not a solution because it's right on a dotted line. And we saw when we did inequalities, if you have a point right on a hollow dot, it is not a solution. So, not a solution. What about the point 5, negative 2? 1, 2, 3, 4, 5, negative 2, right here. No, that's not a solution either, because it's not in the shaded region. The only solutions are the ones that make both inequalities true. That's in the shaded region of both inequalities. So the only one that was a solution was that first point. Now, because this is a little bit more of an advanced lesson, I'm going to show you how you could have not done the problem, but helped yourself by using the graphing calculator. So on your graphing calculator, you can actually graph inequalities. Now, a lot of you, if you hit y equals right now, I have a couple extra buttons down here that you don't have. I have these inequality symbols, but you can get this. Here's how you do it. If you click on the apps button, apps. Now, I don't know how many things you have here. My other calculator does not have near this many kind of random applications on it. But you want to scroll down until you find the one that says inequals. This one has, this calculator has a lot. Oh, there it is, right there. Inequals. You see it? You click enter, and then usually when you click it, it gives you a run option. I'll show it again. Apps. Scroll, 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 scroll. Oh man, I was one short. All right, so you click enter, and it gives you this little Texas Instrument thing. Press any key. Cool. Now, what's different now is when you click on y equals, now it actually gives you these different inequality symbols. So let's type in this first one. So it's already y. Now we need to change this to a less than or equal to. Now, if you try to just hit this button here, the zoom button, it's not going to do the thing you want. Okay, so we need to hit alpha, that button, the little green one, F3. We click that. Look at that. It changed the symbol. Negative x plus 3. Aw, man. Negative x plus 3. And this one was a greater than, and it was usually alpha F1 gives me my fraction thing. It's not giving it to me here. So I'm just going to put 2/3 as a fraction. X, what was it? Minus 2. Now, if I hit graph, you see it's graphing the line, and it's actually doing the shading of the first line. So it's shading, but essentially the blue line here. And then in a second, it should do the red line, and you see its shades going left and right. Except I think I typed in one of them wrong, because these both have negative slopes, and I don't want a negative slope. That's negative, that's positive. Maybe I don't know if the parentheses are screwing this up. Delete. And also we're going to do a zoom standard because my zoom was a little wonky. Let's try this again. And it might be quicker now. Interesting. First off, it's frozen. That's awesome. But also, it's still drawing a negative line. And that's weird because I had my slope as being positive. So I'm not exactly sure what the calculator's doing. Oh, it's giving me an option for shades and stuff. I'm not sure why it thinks that this has a negative slope when clearly it doesn't. Oh, maybe. I think I put a -2 instead of a -2. One more time. We can do this. Don't you love technology? Hey, and that might be an issue you had too. If you put a -2 instead of a -2, maybe we just found an issue together. How about this? While the calculator's graphing, I'm going to move on to the next problem. Oh, there it is. Look at it. Now it has a positive slope. And you can see this double shaded in region here. This is the solution to the system of inequalities. Now, as far as finding whether these points are answers, you still kind of have to do it by hand. You could move the cursor around to find where this is, like -1, -1. And I mean, it's kind of a pain in the butt to do, but you can do it. I mean, I'm trying to get close to -1 here, and there. That's pretty darn close to -1, oh, no. There you go. That's close to -1, -1. It's in the shaded region. So it's not the best, but it is a way you can do this. But it's worth knowing that it could be a helpful backup strategy. Okay, letter B. So let's see here. Well, let's do red since we already have red out. I'm going to graph the top line in red and the bottom line in blue. So I'm going to start by putting in my y-intercept of 3. And my slope is -1/2. So down 1 over 2, down 1 over 2, and again and again. This line will be a hollow line, a dotted line. This is the more ugly way of doing it, but it works. I'm not going to shade yet. A lot of people shade right now. They would shade greater than this line up here. I'm not going to yet. My second line, I'm going to do it in blue, is the line x is greater than or equal to 4. Now, you may not remember how to graph that thing, which is one place where the calculator may come in handy. There's this x equals doohickey up here. There's x equals, where you can change it and just put in one of them and see what that looks like. Oh man, I wasn't sure if I was going to put all of them or not. Oh well, too late now. It's gonna graph all the lines. I didn't delete the other 2. But the way that we did this before is we made ourselves a little table. There, it graphed it right there. That's x equals 4. So when we did this before, we imagined the line x equals 4. So all of my x's have to be 4. But the y's can be anything we want. 0, 1, 2, 3, 8, whatever. So 1, 2, 3, I'm just plotting these points. 4, 0, 4, 1, 4, 2, 4, 3, and you can see what this line looks like. It's going to be a vertical line going through here. And we need this line to be a solid line because this is an or equal to. This would be a solid dot, so it's going to be a solid line. And I missed again. Now, shade. So what I showed you before of shading the one and shading the other and looking for the double shaded in region like this, I don't really personally like this. Typically, when you're looking for the solution to a system of equations, you're looking for the one area, the one triangle, the one piece of pie that is shaded in twice. In this first problem, it's not these 3. It's boom, boom. It is just this. This is the solution to the system of equations. It is this one shaded in area. It's the double shaded area. That's the area that was shaded by the blue and by the red. Now, how I would do that in this problem is, I actually do this. I number 1, 2, 3, 4. I've got 4 sections of pie, 4 sections of the graph broken apart by my lines. And so I'm looking, my first line here, I'm shading greater than the red line. This is my red line. Greater than my red line, means up here. So I know it's not number 4 or number 3. Because greater than the red line is up above the red line. So it has to be either sections 1 or 2. From my blue line, I'm shading greater than 4. Well, which of these has x values greater than 4? Number 2. So I know it's not number 1. So this section is the one piece of pie that has my solutions. This is the only area of the graph that is shaded. Now, if we do the same thing we did previously, and we're looking for which of these points here are solutions to the system of equations. So if I start plotting, so 2, 2, no, he's not in the shaded region. 4, 2, 1, 2, 3, 4, 1, 2. That's a tricky one. He's on the edge of the shaded region. Does that mean he's a solution? In this case, yes, because he's on a solid line. On a solid line means that it's good, it's allowed. On a dotted line, you're not allowed. So this is on the shaded region, on the dotted or on the solid line. This is a solution. 6, 0. 1, 2, 3, 4, 5, 6 is this point right here. Is that a solution? No. Because it's on the shaded region, but it's on the dotted line. Points on a dotted line are not solutions. And lastly, 1, 2, 3, 4, 1, 2, 3 is down here. No, that's not even close to the shaded region. It is not a solution. Okay, here's one I'd like you to try. So go ahead and pause the video, graph these two inequalities yourself, and then find out which of those points are solutions to the system of inequalities. When you're ready to continue, hit play, and we'll go through it together. All right, let's do it. First one we'll do in blue, second one we'll do in red. So the blue inequality, well, has a y-intercept of +1. There's my y-intercept, and a slope of 2. That is 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and in reverse. Because this is or equal to, this is a solid line. And now I go to red. Y-intercept is +4. 1, 2, 3, 4 is right here. And my slope is a -1 over 1. That's down 1 over 1, down 1 over 1, down 1 over 1. And repeat, and repeat, and repeat, forever on both sides. This is a dotted line because this is a hollow inequality. It's not or equal to. So I'll be honest, I kind of like doing the drawing the white through it. There you go. Now, I've got 4 sections of pi. 1, 2, 3, 4. Let's see which ones make both inequalities true. So I'm looking for greater than the blue line, above the blue line. That would be sections 1 and 4. These two are above. If I would go from the blue line straight up, those two are allowed, where sections 2 and 3 are not. And from the red line, I'm looking for less than the red line. That is below the red line, which is down here, less than the red line. That is number 4, which means my solution is section 4. All of this and everything in this shaded region would be a solution to this system of equation or system of inequalities. So when I graph these points, -5, 0, 1, 2, 3, 4 is here. Is that a solution? Yes. 0, -5. I can't even graph that point. That's down here. 1, 2, 3, 4, 5. But it's not going to be in the shaded region. No. 5, 0, 1, 2, 3, 4, 1, 2, 3, 4, 5 is here. No. 0, 5, 0, 1, 2, 3, 4, 5. No. So that was the only one that's a solution. Now, a slight different way you could have done this. Now, these problems all ask you to graph the system of equalities and then find which ones are their points. Did you know you could have found out which of these are solutions without graphing? All you'd have to do is take each of these points. So let's say we did the first one here. If I plugged in a negative 5 for x and a 0 for y in both inequalities, this is the only one that would make both of these true. Let me show you. I'm going to plug in negative 5 for x and 0 for y for both. Come on. There we go. Negative 5 for x and 0 for y. My first inequality, 0 is greater than or equal to, that is negative 10 plus 1 is negative 9. 0 is greater than or equal to negative 9. It works. This math turns out to be a positive 5. Negative 5 is positive 5. Plus 4 is 9. 0 is less than 9. Why, yes, it is. So that point made both inequalities true. If I plugged in any of these other points, actually in this problem, it won't make any of those other equations true. They're all going to be wrong. So that's another strategy you can use. You could actually plug the points in for the inequalities to see which ones work. Ooh, I've got 3 inequalities to graph now. So we'll make a blue, a red, and a green. Okay, so let's go with blue first. Blue, my top equation here, this is the line y equals 5. So I'm thinking of the inequality, or the table, where y is 5. This is the method I actually go through in my head when I'm doing this problem. This is how I graph this. I make this little table, and I just graph 0, 1, 2, 3, 4, 5. 1, 5, 2, 5. And I've got myself a line. So I know my line's going to be horizontal through here. I can see it's going to be a solid line because it is a solid, it would be a solid dot. And I'm not worrying about the shade until the end. My second red line, there we go, is already solved for y as well. So the y-intercept is negative 1. And my slope is 3 over 1. I'm going to go up 3 over 1. That's rise over run. Up 3 over 1. Up 3 over 1. Up 1, 2, 3 over 1. Up 3 over 1. And this is a hollow dot. This is an or just greater than. I'm going to do the ugly dotted line. And then finally, green. This one I have to solve for myself. It's not slope-intercept form. I can't graph this just yet. So I'm going to add 2x to both sides. Negative 3y is greater than 2x minus 6. When I divide by negative 3 on both sides, I'm going to get y is less than, I had to change the direction of that inequality because I divided by a negative 2/3 x plus 2. So that's what I'm going to graph as my green inequality. Y-intercept is 2, down 2 over 3. I can't go any more down this way. I mean, I put a little ghost dot. Down 2 over 3, be something like that. Somewhere out here somewhere. So now my rest of my line's up this way. So up 2 over 3 the wrong way, up 2 over 3 the wrong way, and I almost just drew a straight line through there. But I need it to be a dotted line, not a solid line. It's just less than. So, and the good news is, as long as your dots are accurate, your line doesn't have to be super duper accurate. Now let's see, I've got 1, 2, 3, 4, 5, 6. I've got 7 different sections of the graph. There's the tiny little triangle here. 1, 2 is this area above the blue line. 3, 4 is all of this. 5 is this little triangle in the middle. 6, and then 7. So now I'm going to start figuring out which of these sections make these different inequalities true. So I'm going to take my eraser tool. I'm looking for lines that are, or points, sections that are greater than 5, greater than this blue line. Well, that's 1, 2, 3. Already I can cross off not 4, not 5, not 6, not 7. It's everything above the blue line, greater than 5. From my red line, I'm shading greater than the red line, above the red line. That crosses off number 3. Number 3 is below, down from the red line. We want above it. And lastly, my green line. Because we changed the direction of the inequality, this is now a less than. We're looking for lower than the green line, which would be number 1. So number 2 is out. My solution is, well, on the piece of graph we have is just this tiny little section here. But remember, this is not just this tiny little section. This on a coordinate graph extends forever and ever and ever and ever all this way. Okay, so it just looks like a tiny section here, but these lines do go on forever. So there's actually a big section over here. So let's see which of these points make this true. Would 2, 0 make it true? No. Would 0, 6? 1, 2, 3, 4, 5, 6. No. Would 0, 5? 0, 5. I didn't plot 0, 6. There's 0, 5. Would 0, 5 make it true? No. It's not in the shaded region. Would negative 5, positive 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Actually, that one's going to be a yes. It's on a solid line that's bordering the shaded region. That is a yes. He is a solution to this system of inequalities. Okay, here's one for you that has 3 inequalities as well. Go ahead and pause the video, graph these 3 on your own. When you're ready to continue, hit play, and we will go through it together. All right, so let's do it. I've got blue, I've got red, I've got green. Let's go with blue first. So this is the line y equals 3. As far as the up, down, left, rightness of it goes, so that's the table in my head when y is 3. 0, 1, 2. That's what I'm graphing in my head. That's the line that I draw. 0, 1, 2, 3. 1, 3, 2, 3. I can now see that the line looks like this. I can see the line should be a solid line, so I'm just going to make it solid. There's my blue line. Red line. This is the line x equals negative 4. That is the table, negative 4, negative 4. All of the x's are negative 4. Y is anything you want. So why not something easy? Negative 4, 0. Negative 4, 1. Negative 4, 2. So the line would go right up and down straight through here. But my line needs to be hollow. And this is not or equal to. This is a hollow line. So I'm actually just going to draw this one and then make it white. I'm going to white out the pieces. And then my green line. He was already y equals. I did not have to do any solving, which made our lives easy. So the y-intercept is positive 7. 0, 1, 2, 3, 4, 5, 6, 7 is here. My slope is down 1 over 3. Down 1 over 3, down 1 over 3, up 1 over 3 the wrong way. So there's all my lines, my dots. This line here needs to be a dotted line because of the inequality. I'll do the ugly dotted line for this one. And now on my graph, I see there's section 1, 2, 3, 4, 5. My 5's a little hard to see. There you go. There are more sections. Like there would be where these lines crisscross up here in outer space, there'd be a section up here where these two crisscross. I can't even move my graph over far enough. This one, as it keeps coming down and this one goes across, there's another section over here. But we know that those aren't part of the solutions because they're not in the shaded region. I mean, they're not in the graphed area that we see, so we don't have to really worry about them. So let's see here. From my blue line, I'm shading less than the blue. That's from the blue line, less than, down, less than that. So not you or you or you. From the red line, I'm shading greater than the red line. From the red line, greater than. Which way of the red line shows x values bigger than -4? This way. -3, -2, -1, 0, 1, 2. These are bigger than -4. We didn't even need this third equation. I mean, technically we do. Less than the green line. Yes, this area here is less than the green line. So this area here is our shaded region. This is our solution to the system of equations. This one area here that is below the blue, to the right of the red, and below the green. So let's see which of these points are solutions. Is the point 2, 0 a solution? Yep. Is the point 0, 6? 0, 1, 2, 3, 4, 5, 6. Nope. It's not in the shaded region. 0, 5. 0, 1, 2, 3, 4, 5. Nope. And then finally, -5. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Nope. That is the only one that's in the shaded region. So that's the one point that's a solution. That is the one point that would make all of these true. The y value is less than 3. Yep. The x value is greater than -4. Yep. And if we plug in the x for the x and the y for the y, this inequality is also true. It's the only point that makes all three equations work. Now, the other thing we should be able to do is kind of the reverse of this. Given a system of inequalities, we should be able to write the equations or the inequalities that match it. So I'm going to call this the blue line, and I'm going to call this the red line. That way we're all talking the same language. So from this blue line here, things I know. Well, first off, my equation is going to be slope-intercept form. So y something mx plus b. Okay. I know the y-intercept is -1. So, I mean, if you imagine your actual equation like y equals mx plus b. So here's my x. My y-intercept is -1 right there. My slope, up 2 over 2, up 2 over 2, which is the same as up 1 over 1. So my slope is 1. We don't really need to write the 1. I was going to put a ghost 1 in here, but we don't need to write that. It's extra information. We can simplify by erasing it. So this is the better way of writing a slope of 1. That's 1x. The last thing we need is the right inequality. From here, I'm shading less than the line, so let's put in the less than symbol. And my line is dotted, so it needs to be a just less than, not or equal to. There's no or equal to here, or else this would be a solid line. So it's all these little pieces that make this up. The dottedness, the angle, the y-intercept, the shade, all of them are represented in the equation, in the inequality. Okay, red line. Y something. Well, it's going to be a less than. We're shading lower than the line, and it's a dotted line, so it's not or equal to, it's just less than. So y is less than something x plus 1. Y plus 1? Well, because that's my y-intercept. My y-intercept is a positive 1. Now, what's my slope, my missing piece? Down 1 over 2. Down 1 over 2. Down 1 over 2. So my slope is down 1 over 2. Negative 1/2. Rise over run. This is my system of inequalities that matches the graph. Another example. Make this one the red line, and we'll make this one the blue line. From the red line, things I know. Okay, so first off, slope-intercept form looks like this, in case you forgot. So y is less than or equal to the red line. It's lower than a solid line. Less than or equal to. Lower than a solid line. My y-intercept is negative 3. And my slope is up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2x. That is the equation of my red line. Of my blue line, y, this is a dotted line, and it's greater. So I need a greater than, but not or equal to, because it's dotted. So y is greater than this line. That has a y-intercept of negative 3. See? They share the same y-intercept. But now instead of the slope being 1/2, my slope is up 1 over 1, 2, 3, 4. 1/4 x. Boom. And that's done. If you're finding yourself struggling with this, I'd recommend maybe rewinding and watching maybe just this problem again. Now that you've seen the answer and you see how it goes together, make sure you understand why each of those pieces go the way they are. Why is this y-intercept negative 3? Well, it's right there. How'd you get 1/2? Well, from the red line, slope is up 1 over 2. How did you know it's going to be an or equal to? Well, because this red line is a solid line, and solid lines have the or equal to. Stuff like that. But here's what I'd like you to try. So if you could, please go ahead and pause the video. Try this one on your own right now. When you're ready to continue, hit play, and we'll go through it together. Okay, I'm going to make that the blue line and that the red line. So starting with the blue line. Things I know. I know my y-intercept is going to be a 0, so I'm going to erase that plus 0 in a second, but I'll leave it there for now, just so we have a placeholder for it in our problem. I know that I'm shading less than a solid line, less than or equal to, and my slope is down 1 over 1, down 1 over 1, down 1 over 1, which gives me a slope of negative 1 over 1, which is just negative x. If I simplify the problem, I can get rid of those pieces. They're not needed. That's the equation you would see in a textbook. That is equivalent to y is less than or equal to negative 1 over 1 x plus 0. I mean, it's the same thing, but one of these is definitely better than the other. Okay. This top equation, you're not going to see this in a textbook. There's a lot of extra junk. And by nature, mathematicians, we're fairly lazy people. We're not going to write more than we have to. I'm not going to write a +0 if I don't have to. I'm not going to put this 1/1 if I don't have to. These are the same. This one is better. So if you had this equation, or even just the slope part, maybe you want to simplify it now. Okay. We're getting to the point that you should be a little bit more advanced and should be able to do this simplification on your own. My red line. Let's see. So my red line is y is greater than. It's above a dotted line. That's a greater than. Something x minus 3. My y-intercept is -3. As far as my slope, it looks like it is down 1/1. Down 1/1. It's the same kind of situation as this, which I'll be honest, I knew because these two lines are parallel, so they're going to have the same slope. The slopes are the same because they're parallel. We learned that earlier talking about systems of equations. And I think we're done. That is the system of equations, or system of inequalities, that matches the shaded region. Let's try one more. So why don't you go ahead and pause and try this video or try this problem on your own. When you're ready to continue, hit play and we'll go through it together. All right, so we got red line here, we got blue line here, and we've got green line there. So let's do red first. Red line is the line x is greater than -3. It's a vertical line which has been the x equals, and this is a value of -3. I know it's greater than because I'm shading to the right of it, so greater than -3, and it's a dotted line. My blue is the line y is less than or equal to. I'm doing that because it's lower than the blue line. It's on a shaded region, so it's or equal to 1. That's a y value of 1. And my green line, y is greater than or equal to. Greater than or equal to because I'm shading above a solid line that has a y-intercept of -1 and a slope of 1/3. I just counted right in here in my head. Up 1/3, up 1/3. That is the system of inequalities that matches the graph. Problem solving. Write an inequality for the values of m that make the point 1, 1 a solution to the system of inequalities. So we need to figure out what values of m make 1, 1 a solution to the system of inequalities. So let's start figuring this out. So it seems a little confusing, right? I'm going to start by graphing this line. So let's see what happens. I'm going to graph this line right now. So this is the line that has a y-intercept of -2, a slope of 1/3, and this should be a solid line. And we're shading above. We will be shading greater than this line, so up here. This second one, well, we can't really graph it too exactly because we don't know what the y-intercept is. Things we do know. Well, we want the point 1, 1 to be a solution, so let's plot him. Boom. And I guess I do know that this line has a slope of -2, so let me draw a line with a slope of -2. Using notability, I can always move the line around wherever I want it. So let's draw this line with a slope of -2. So I'm just going to draw, starting here, I'm going down 2 over 1, down 2 over 1. There. That line has a slope of negative 2. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay? Now, I can take this and I can move it wherever I want. And I know I want to shade less than this line. Ooh, he should be a dotted line, shouldn't he? We'll make him dotted in a little bit. Right now he's solid just because I have to move it around. It'd be hard to move a whole bunch of dotted things around. So where would I need to place this line so that this dot would be in the shaded region of both? I'm in the shaded region of the blue. Here, let me actually do the double shaded thing. So from the blue, I'm shading above. From the red, I'd be shading less than. So where would I move my red line so that he's in the shaded region of both? Well, as soon as my red line kind of crosses here, this boundary, now it's in the shaded region, isn't it? Ignore the fact that the shaded region just kind of cuts off here because I didn't have enough space, but it would still be in the shaded region way even over here. Like, I mean, if I can draw more shaded if you want. There you go. There. Now I got a big shaded region. So my shaded region kind of extends further. So as soon as my line crosses here, well, what y-intercept is that? What is the y-intercept of this red line? It's 0, 1, 2, 3. So I know the solution is something about m and 3. But is it equals 3? Let's check. Write an inequality for the values of m that make this point a solution. So, well, I guess it's not equal 3 because check this out. If I make m, whatever this is, that means the y-intercept to be way up here somewhere, 15, 20, 30. That point's still a solution. So it's m values greater than 3. The last thing we have to figure out is it greater than or equal to? Would that be a solution? And before you answer, let me go through and add my dotted lines back in. I know it looks really ugly now because of all the shaded stuff, but remember this red line was supposed to be a dotted line. Is the dot allowed to be on a dotted line to be a solution? Nope. So it's only when my line is greater than 3, has to be bigger than 3, that it's a solution. Anything over here, it could be 4, 5, 6, 7, 8, 9, 37. The dot will be in the shaded region of both. So that's a fairly complex problem, but the problem-solving process was, well, let's just kind of graph some stuff, graph what we know, move some stuff around, manipulate some stuff, and see what we can figure out. The answer is, when m is 3, that point will be a solution to the system of inequalities. I'm going to have you try this one. It says, which inequality, when graphed as a system with the currently graphed inequality, would have the points 4, 0, and 6, 1 as solutions? Okay, so go ahead and pause the video and try this one on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so I'm going to start graphing. So this first one is 1, 2, 3. Oh, I should actually probably graph these 2 points while I'm thinking about it. So point 1, 2, 3, 4, 0. All right, cool. And 6, 1. So I'm looking for which lines make these 2 solutions of both. It's already a solution of this graph line, but which of these guys would these 2 points still be a solution? So let's see. So I graphed, there's the y-intercept, and then up 2 over 1 would be like over here, down 2 over 1, down 2 over 1, down 2 over 1, it is a dotted line. And I would be shading less than. You know what? I think that might be the answer. I mean, if I have my shaded regions, I already know it can't be 1 or 2 because it has to be in the shaded region of this gray boxy area. But less than, oops, I'm sorry. How about we read the problem properly? It's a greater than. So no, it's not this one because greater than this line would be section 4, not section 3 above this. So there we go. It is not letter A. Okay, how about letter B? The y-intercept is 0. The slope is up 1 over 2, up 1 over 2, up 1 over 2. And my line is a solid line. And my shade is greater than. Nope, that is not going to be a good answer because it's, well, the dots aren't in the shaded region of both lines. Letter C. Y-intercept is 3 again, just like before. Down 1 over 1. It is a solid line. I'm sorry, a dotted line. My goodness, I keep making mistakes today. And I'm shading greater than. That's above. And I think we actually have a winner this time, because that makes these two dots in the shaded region of both inequalities. Now, for completeness, you're usually supposed to check the last choice as well. If I graph the last point, the last line, it looks like this. And it would be shaded to the right. This would not be a solution because this point would be on the dotted line, which means this one point would not satisfy this bottom equation. The other way we could have gone about this same problem is, instead of graphing each of these, which I think is probably the right way to do this, but instead of graphing each, we could have plugged in 4, 0 for each of these and plugged in 6, 1 for each of these and see which one equation makes both inequalities true. So it's another strategy. Summary. Which method of solving equations algebraically do you like best? Or even systems of equations, systems of inequalities. Which way do you like the best and why? Because you've learned substitution, you've learned elimination, and really that comes down to opinion. I personally like the elimination better. I don't like substitution as much. I typically find it to be more work, but some people really like it. Okay, this is it for now, systems of equations and systems of inequalities. Thank you so much for watching this lesson, and until next time, toodles.